Welcome to the lecture Interfacing of Stepper Motor and Opto Isolator with 8051. Stepper motor is a brushless motor which converts electrical pulses into mechanical rotation. The stepper motor rotates in steps according to the input pulses. It usually have number of field coils, these are called as the phases, and tooth rotor. The step size of motor is determined by number of phases and number of teeth on the rotor. Step size is the angular displacement of the rotor in one step. This generally stepper motor has 4 phases and 50 teeth. If it is so, then it takes 50 into 4, that is 200 steps to make one complete rotation. So step angle will be 360 by 200, that is 1.8 degree. So we can use this motor for the precise rotation angle. This is the internal schematics of the stepper motor. It has 4 coils A1, A2, A3 and A4, and the common terminal of this coil are connected to VCC. So these are the 4 phases of stepper motor. To rotate this motor, we have to give the excitation to phases in proper order. So the stepper motor is rotated by switching individual phases on for a given time one by one. For example, here one sequence is shown. So during first time period, this A1 coil is energized. So supply is connected to this A1 coil for some specified duration. After that, A2 coil is excited, then A3 coil and then A4 coil. To rotate this motor continuously, we can repeat this sequence. As an example, here different motors which are available with different steps angles are shown. For example, motor with step angle 0.72 is available. So if we are using this motor, it will rotate with the step angle of 0.72 degree. So for one complete revolution, we need 500 steps. If the motor is of 1.8 degree, generally this motor is used. It needs 200 steps to complete one complete revolution. So like that, different motors are available. Steps per second we can compute using RPM multiplied by steps per revolution divided by 60. There are two different modes to drive a stepper motor. The first is full step mode. In full step mode, 2 electromagnets are energized at single time. So torque which is generated in this mode will be greater. Power consumption is higher in it because we are exciting 2 coils at a time. This type of motors are chosen when torque is more important than power consumption. The second mode is half step mode, and in half step mode generally one electromagnet is energized at a time. These electromagnets are energized alternately. This method has low torque but the angular resolution is double. So this type of motors are chosen when we want to increase the angular resolution of the motor. Just go through the sequence which we have to give to the phases of stepper motor in full step mode. This is a dual phase mode. The motor operates in both phases, get energized at the same time. 2 opposite coils are excited at a time. This method provides more torque and higher speed performance, but it requires twice the amount of power used in one step mode. So here the coils are named as A, B, C, D, and Here the coils are named as A, B, C, D, and these are the steps in which we are going to energize particular coil. For example, in step 1, coil A and coil B are excited. So we'll send logic 1 through microcontroller to coil A and B. After that, this coil B and C are excited. In next step, C and D are excited. And in last step, fourth step, coil A and coil D are excited. If you give a sequence in this direction, then motor will rotate in clockwise direction. If we reverse this sequence, that means if we provide a 4-step sequence first and then we'll go towards the step 1, then motor will rotate in anti-clockwise direction. So direction of this steps or sequence of step decides the direction of motor rotation. So this is the clockwise direction and this sequence is for anti-clockwise direction. In half-step mode, the coils are energized alternately. The rotor moves through half the base angle in a single step, which results in improved torque than single-phase full-step operation. Also, it doubles smoothness of rotation and resolution. In this mode, only half the basic step angle is used compared to full step mode, which result in more precise motion control and smoother motor performance. Resolution is also increased, but this mode produces less torque. So this is the sequence for half step mode, and if we follow the sequence in this order from step 1 to step 8, then motor will rotate in clockwise direction. If we reverse this, motor will rotate in anti-clockwise direction. Go through the interfacing diagram of stepper motor with 8051 microcontroller. This is 89S52 IC and we have connected this stepper motor M1 to this IC through driver IC ULN2003. ULN2003 is used for driving the individual phases of the stepper motor. It is a Darlington transistor array IC and it is used for driving high current loads such as relays and motors. This ULN2003 has 8 individual channels, each with 1 ampere capacity. The channels can be parallel to increase the current capacity. Each channels are fitted with individual freewheeling diodes, and this IC operates in current sinking mode. Each channel is activated by giving a logic low at the corresponding input. For example, if you make pin P1 of ULN2003 low, then phase A of this motor gets switched on. So when we provide logic 0 here, the particular coil will be switched on. The assembly language program to rotate stepper motor continuously in clockwise direction. Here I have used a full step sequence. So this sequence we can convert in hex. So for first sequence, if we convert it into hex, we'll get a value 0CH. So here I have used full step sequence. If we convert the steps into hex number, then for first step we get a value 0CH. And if you observe it, after for each step, if we rotate this step 1 count in right direction by 1 bit, then we get a second step count. If we rotate second step count by 1 bit in right direction, we'll get the third step and then the fourth step. So we'll use this logic to write a program. So first in accumulator, the count or data for first step is stored, that is 0ch. Then we'll move this data or we'll place this data on port P1. So the particular phases of the stepper motor will be energized. Then we'll rotate this step in right direction. We'll rotate the accumulator in right direction by 1 bit and we call a delay. So depends upon delay, this we can change the speed of the stepper motor. And we'll continue this rotation because we want to move the stepper motor continuously in clockwise direction. For delay, we can write any simple delay program. Here using register R2 and R3, delay program is written. So this program will rotate motor continuously in clockwise direction. Now we can write a program to rotate motor continuously in anti-clockwise direction. So for that we'll use a reverse sequence of this full step. So first we'll send a sequence which is used for step 4, that is 09H, and then we move it in the left direction, rotate this sequence in the left direction so that we'll get a third step sequence, second and then 1. So for that we'll send this sequence on port P1. We'll rotate this contents of accumulator left by 1 bit. We'll call a delay and we'll execute this program continuously. Again for delay we can write a simple delay program. Opto isolator is also called as optocoupler, photocoupler or optical isolator. It transfers electrical signal between two isolated circuits by using a light. So as shown in this diagram, here for transmission the LED is used which will transmit a light, and this light will be captured by the photodiode or phototransistor at the receiver side. So here the transmission is through light. So because of this there will be a isolation, proper isolation between a high power circuit and the low power circuit. So it avoids the damage of low power circuit. In case of power electronics application, we need to isolate a triggering circuit from the power circuit, because power circuit needs a high voltage and triggering circuit works on very low voltage. So to avoid the damage of this triggering circuit, we can isolate triggering and power circuit using opto isolator. It provides electrical coupling between input and output through light waves, and it prevents high voltages from affecting the system receiving the signal. Its main purpose is to avoid changing in voltages at output side to appearing at input side. Higher voltage fluctuation may damage input side electrical component. So this circuit avoids damage of this lower voltage circuit from the higher voltage circuit. Many types of optocouplers are available in market according to their rating and design, like fast opto isolator, analog opto isolator, linear opto isolator. The rating of these optocouplers depends on output voltage drive capacity of isolators. The mostly used opto isolators are for maximum output voltage 30 volt, 70 volt, 80 volt. They can easily operate between the temperature range 70 degrees centigrade to 150 degrees centigrade. The most commonly used opto isolators are 4N25, 4N26, ILD74, PC817 and many more opto isolators are available. As per our application, we can select these opto isolators. Now go through the interfacing diagram of opto isolator with 8051. Here the lamp is used as a load. So whenever there is a signal to this lamp through opto isolator, it will turn on. This is 12-volt lamp signal. So whenever this opto isolator start working, that means current flows through this transistor, phototransistor, the circuit completes and this lamp turns off. So when we provide here logic 0 on P1.0, this LED will glow because its anode terminal is connected to plus 5 volt supply. So when LED glows, it focuses light on this phototransistor, and current will flow through phototransistor and this lamp will glow. When we send a logic 1, this device is off and hence no current will flow through this phototransistor and lamp turns off. IC used here is ILD74 opto isolator. It has two pairs of opto isolator, so we can connect two different devices through this opto isolator IC. Just go through this simple program to turn on and off this light continuously. So we first send a logic 0 to LED or input terminal of opto isolator. It will turn this light on. We call a delay, and to turn this light off, we'll send a logic 1 to input terminal of opto isolator. Again we call a delay and we'll execute this program continuously. So light will continuously turn on and off with this delay. The same delay program is written here. We can write delay program using timer also.